In this video, we're going to graph a rational function. Negative x plus 6 divided by x squared minus 36 is a rational function. It's a ratio of two polynomials. What we need to do is find all of the following before we graph. We are always interested in the domain. We want asymptotes. There's three types: vertical, horizontal, and slant. So we're going to decide if it has those, and if it does, what they are. We'll also see if there are any holes. Horizontal, slant, we'll look at the intercepts, x and y, and with all that information, hopefully we'll be able to graph it. We may need a couple extra points, but let's find out. Let's start with the domain. For rational functions, we're always interested in finding when the domain is 0. Whatever values cause us to divide by 0 are the values that we have to exclude from the domain. So I want to always factor these guys if I can. This is my function f factored. Before I answer the domain question, I just want to look at that numerator. I can see that I might have like factors in the top and the bottom, which will help us determine where the holes are, if you remember that. So I can factor a -1 out of that. That's a trick we do fairly often. And I can see that the factored form of this rational function looks like that. Okay, now be careful, don't cross out your x minus 6's. That will give us a slightly different function. I want to leave those in there. They'll help me figure out which is a asymptote and which is a hole. Okay, but first, before I get there, the domain. Write my domain in blue. The domain looks like this. It's all values for x, as long as it's not the values of x that cause me to divide by 0, which would be the plus and minus 6. Right? If x is 6, I'm dividing by 0. If x is -6, I'm dividing by 0. If you don't see that, the general rule is to set each factor to 0 in the denominator and solve like this. Right? That's the work involved that maybe we don't have to do. That causes me to divide by 0, so I say he's not allowed. All right? Now, the vertical asymptote occurs at x equals -6. Right? It happens with the 0 that corresponds with that factor right there. All right, because as you get closer and closer to -6, you're dividing by a really small number. That's that asymptotal behavior. Over here, as you get closer to 6, what's happening is that whatever values are close to +6 are crossing out with the numerator, right? So at x equals 6, you have a hole. All right. At x equals 6, there is a hole. All right, moving along. Horizontal asymptotes. So let me bring this function with us to the next slide. Horizontal asymptotes, we've learned that if the degree of the denominator is larger than the degree of the numerator, which in this case it is, the degree in the denominator is 2, right? The degree in the numerator is 1. So that means your horizontal asymptote is y equals 0. As x goes to infinity, the denominator gets so much bigger, your whole fraction goes to 0. Slant asymptotes, there are none. Remember, when a slant asymptote occurs, when the degree of the numerator is 1 degree more than the degree of the denominator, and when you divide, your result is a linear or a line. In this case, that is not happening. We have a horizontal asymptote, so we do not have a slant asymptote. X-intercept would occur when the numerator is 0, right? And if I were to solve that equation, that's generally the process. Set your numerator to 0 and solve. And the answer to that would be x equals -6. But of course, this is not in the domain, right? We've already established that our domain does not include the number -6. So there are no x-intercepts. And there's going to be a y-intercept when x is 0, right? So we can plug in 0, and all your x terms would go away, and you get that value, right? That corresponds to the point 0, -1/6. So that's our y-intercept. Okay, let's put all that stuff on our graph and see how much it helps us. 0, -1/6, that's barely right about there. Okay. We had a vertical asymptote. Let's go back. Horizontal asymptote happens here at the line y equals 0. So normally we do a dotted line. In this case, it's right on the x-axis. So maybe we don't need it, but I'll put it there in green. We have a vertical asymptote at x equals -6. So we start to get the idea of what's happening here. The asymptotes really help us graph our function. Okay, and we have my y-intercept went away right there. Okay, so that's all we got. We got no x-intercepts. We have one y-intercept, and we have those two asymptotes. We know that there's a hole in the graph at x equals 6. We don't really know yet what the vertical or what the y value would be there. But we do know what happens as x goes to infinity, right? It hugs these curves. So I'm going to graph my function in red. So as I go this way, I know it's got to do that. Right? Now some of these guys will cross a horizontal asymptote and hug it on the other side. So we can pick some values like f of 6 and f of 8, make sure they're barely negative to verify that. What I want to do is just see kind of what's happening as I get closer to this vertical asymptote on both sides. Okay. So these test points I'm going to pick on either side of this vertical asymptote just to give me an idea of where the graph is on either side of that. So I'll pick f of -8 on the left and see what the y value is, or -8 for x and see what y is. And on the other side, how about -5? I'll just do these two test points. You could do a couple more to get, but you know the idea or the general shape of these rational functions because it's going to hug these asymptotes. So asymptotes really help shape the curve. So a couple test points might give us a good idea of what's going on. So the numerator is -x plus 6. And in the denominator, I'm looking at x squared minus 36. So what does that give me? That's 14. I'm sorry, yeah, 14 on the top. And in the denominator, 64 minus 36, I believe, is 28, which is a half. So -8 comma positive 1/2 right there. That looks good to me. Now plug in the -5, -x plus 6 on top. And on the bottom, 5 squared minus 36. That should be a negative value, so that's what 11 over 25 minus 36 is -11. So that gives me -1. So let's see, that's -5, -1. Okay, so that kind of fits what's happening here on the right side. All right, we have that sort of behavior as you start to hug the axis, and you've seen this before with these functions. This is what they do as they get close to the asymptotes. On the left side of this, I only have 1 point, but pretty confident that it's going to do that. Okay, just because I know what happens as we approach these asymptotes. All right, and the one thing I'm missing here is my hole at x equals 6. We know that there shouldn't be an output there. There should be a hole, which I'll indicate by drawing a hole. Okay, because we know that x equals 6 is not in the domain. And that is the graph of that function.